Hi there, in the previous video I went through the result in order to work out the acute angle between two lines. So the result being cos theta, so theta is the angle between your lines. That is the absolute of m1 dot m2 over the modulus of m1 times modulus of m2. Okay, so let's go over some examples rather. So let me show you how this result is applied. So example 1, let's find the acute angle between the following lines. So here's a part A. So the first line is given by r is equal to I plus 2k plus lambda into I plus 2j minus k, and the second line is given by r is equal to 2i plus 3j minus k plus mu into 3i minus j plus 2k. So let me show you how this formula works. So let me break down the method into steps. So step 1 is we need to find the scalar product. So we need to find a scalar product, and remember in the previous video this formula only depends on the direction vectors of your lines. So this formula only depends on these two direction vectors. So let's work out m1 dot m2. So I'm going to take m1 as being the direction vector of the first line and m2 to be the direction vector of the remaining line. So m1 is I plus 2j minus k, and applying the scalar product of that to m2, which is 3i minus j plus 2k. Okay, so scalar product implies multiplying the coefficients of I, j and k and add. So if I multiply the I components, I have 1 multiplied by 3 plus multiplying the j components, I have 2 multiplied by minus 1 plus multiplying the k components, minus 1 times 2. So minus 1 times 2. Okay, so if we expand the brackets, 1 times 3 is 3, 2 times minus 1 minus 2, minus 1 times 2 minus 2. So simplifying further will give us m1 dot m2 is equal to 3 minus 2 is 1, 1 minus 2 minus 1. Okay, so that is step 1, working out that scalar product. Now in step 2 we also need the modulus of m1 and the modulus of m2. Okay, so I'll call that step 2. So in step number 2, so let's take a ruler. Step number 2 is let's firstly work out the modulus of m1. So looking at m1, so here is m1, so it's I plus 2j minus k. So if I apply the modulus, so it's the square root of coefficient of I is 1, so it's 1 squared, plus coefficient of j is 2, so 2 squared, plus coefficient of k minus 1, so plus minus 1 squared. Okay, so that is the modulus of m1. Let's do the same with m2. Okay, but let's simplify this before applying the same calculation to m2. So modulus of m1 will be 1 squared is 1, 2 squared being 4, minus 1 squared 1. So I'm going to leave the answer as root 6. Okay, so that is the modulus of M1. So let's do the same calculation for M2. So M2 is 3i minus j plus 2k. So if I take the modulus of M2, so it's the square root of, coefficient of I is 3, so 3 squared, plus coefficient of j is minus 1, so it's minus 1 squared, plus the coefficient of k being 2, so 2 squared. So if we simplify further, we'll have the root of 3 squared being 9, minus 1 squared 1, 2 squared 4. So that will simplify to root 14. Okay? So that is step number 2, that's the end of step 2. And step 3, we have everything that we need to apply the formula. So step 3 is to apply the formula. So using cos theta, that is the absolute, so it's the absolute of m1 dot m2 over the modulus of m1 times the modulus of m2. So cos theta, that is equal to the absolute. Now looking at step number 1, m1 dot m2 we had minus 1, so we have a minus 1 in the numerator over modulus of m1 is root 6, so over root 6, and modulus of m2 root 14. Okay, now be careful when doing the calculation, because first you need to take that absolute. So absolute of a negative number is a positive number, absolute of a positive number remains positive. So absolute of this term, let's make it 1, so ignoring the minus, 1 over root 6 into root 14. But we need to calculate theta, so we need to apply the inverse cos of this term. Okay, so let me check with the calculator. So let's have a look. So 1 divided by root 6 into root 14. And if we take the inverse cos of that, we should have something like 83.7. Okay, so it's 83.7 degrees. Okay, so that is what we should have. Okay, and you could double check this using your calculator. Okay, and also bearing in mind that the angle that you calculate is acute, that angle should be less than 90 greater than 0. Okay, and this angle indeed is that. So that completes this example. Let's try another one. So in part B, so same question but different equations. So the equation of the first line is given by r is equal to I minus 3k, so I minus 3k plus a lambda open a bracket 2i minus j plus 5k, and the equation of the second line is r is equal to I plus 3j minus k plus mu into 3i plus 2j minus 2k. So these are our vector equations of the lines given. So remember, the formula only depends on the direction vectors. So immediately I'll circulate those, and I'll call this one M1, the direction vector of the first line. I'll call this one M2, the direction vector of the second line. Okay? So going back to the method, step number 1 is M1.M2. So let's do that calculation first. So step number 1, M1.M2. So M1 is 2i minus j plus 5k, dotted with 3i plus 2j minus 2k. So let's calculate the scalar product. So if I multiply the coefficients of I, we have 2 into 3, plus multiplying the coefficients of j, minus 1 into 2, plus multiplying the coefficients of k, 5 into minus 2. Okay? So if you evaluate that, you might find that you're going to get an answer of 2 into 3, which is 6, minus 1 into 2, that is minus 2, 5 into minus 2, minus 10. Okay? So further to that, 6 minus 2 is 4, 4 minus 10 minus 6. So that is M1 dot M2. Okay, so that completes step 1. Now remember, step 2 is to work out the modulus of M1, modulus of M2. So let's have a go. So step number 2, modulus of M1. So looking at our vector, M1 is 2i minus j plus 5k. So if we take the modulus of that, we're going to have the square root of coefficient of I is 2, so 2 squared, okay, plus coefficient of j is minus 1, so minus 1 squared, plus coefficient of k is 5, so 5 squared. So if we expand the brackets, so let's have a look. 2 squared is 4, minus 1 squared being plus 1, 5 squared are 25. So I'm going to leave this as root 30. Okay, so that is modulus of M1. Okay. So in the same way, let's work out the modulus of M2. So let's remind ourselves of M2. So M2 was 3i plus 2j minus 2k. So 3i plus 2j minus 2k. So let's work out its modulus. So it's the square root of coefficient of I 3, so 3 squared, okay, plus coefficient of j is 2, so 2 squared, plus coefficient of k minus 2 squared. So if we simplify this, the modulus of M2 will be 3 squared is 9, 2 squared 4, minus 2 squared plus 4. Okay, so 9 plus 4 plus a 4 is 17, so I'll leave it as root 17. Okay, so that completes step number 2. So in step number 3, if you remember, is the application of the formula. So we've got everything that we need to use the formula. So let's apply that formula. So using cos theta, that is the absolute M1 dot M2 over the modulus of M1 times the modulus of M2. So if I replace our results from the previous steps. So m1.m2, if you remember, is minus 6. So it's going to be the absolute of minus 6 over modulus of m1, that was root 30, times modulus of m2, root 17. Okay. Now remember, take the absolute first. So taking the absolute will give us 6 over root 30 into root 17, and then apply the inverse cos of this. So if you apply the inverse cos, you should have 74.6 degrees. Okay, so that's the solution to this problem. So those were the steps in order to work out the acute angle between two lines. Okay, so I hope you found this video helpful. Okay, and do related practice problems, and I hope to see you in the next video. Thank you.